Another important concept of this is the concept of equivalent force systems. So let's consider a body omega that we have here, and the body is subjected to a force system. So this force system here, Fi, and I have the exact same body omega, but now subjected to a second force system, so Fj prime. And what I like to do is define the concept of equivalent. And to be able to do that, we have to have some notion of what we mean by equivalency. And the notion that we mean by equivalency is that the effect that the forces have on the body is equivalent. And so the way we do that is we say that two force systems are equivalent, meaning that they produce the same effect on the body when we consider the body to be a rigid body. Okay, so this is completely a rigid body concept. However, we do use it later on when we are looking at the analysis of deformable bodies, and in that context, equivalency simply means that produces almost the same effect. Okay, and we'll define that a little bit more clearly when we move on to deformable bodies. But for rigid bodies, the concept means produce the exact same effect on the body for two different force systems. And for that to occur, well, all we have to have is that the net total resultant force from one force system is equal to the net resultant force from the second force system, and that the moment from one force system is equal to the moment from the second force system when we use the same reference point. So in this case here, I've picked some origin, O. We can put it right here, say in the bottom corner. There's O, and the bottom corner over here, O. So when we compute the moment relative to that same reference point, we need to get the same resultant moment. And that's the concept of equivalency that we mean. One thing that's important to note about equivalency is that if you show equivalency with respect to, say, one point A, then that also implies equivalency with respect to another point B. So in other words, when I pick the reference point to compute the moments. And this is relatively easy to prove. So let's suppose that we have already equivalency. So we have R equals R prime, and we have that the moment relative to some reference point, let's say point A, is the same for two force systems, F and F prime. And what we need to be able to show is that the moment, the resultant moment relative to a new point B in the body produces the same moments also. So let's draw a picture first of what we mean. So we have a body. So here's our body omega, and we have our reference point A and our reference point B. And I've drawn in here the connecting vectors from B to A to I, and from B to I. Okay, so this is our setup. And let's start with the expression for the moment relative to B. I want to show that the moment relative to B using one force system, the unprimed force system, is equal to the moment relative to B with respect to the F prime system using two facts, using the fact that the resultants add and that the moments about A are the same. Okay, so I have the definition of the moment about B. It's just the cross product of the position vectors to the forces. So this is for the unprimed forces. And now I'm going to replace the vector from B to I, so that's this guy here, by the path going from B to A and then A to I. Okay, so that's just RBA plus RIA, and then we have the cross product with the FI. Well, I can go ahead and use the distributive law of the cross products, and what I'll find is that from the first term, this cross product with RBA, I get RBA cross R, and the second cross product is going to produce the resultant moment about A just by definition. Okay. Now let me go ahead and use another fact here, and that's simply that the moment about A is equal to the moment of the prime system about A, and also that the resultants are the same here. So I'll put the prime in there. We only have one R, so you don't really have to put the prime, but let's go ahead and write that in there. So if I look at this expression, this is actually just a change of reference point expression that we had developed in our last set of lectures. So we end up with that the resultant moment about B is equal to the resultant moment about B for the prime forces. Okay, so and that's what we wanted to show. So we've proved that having equivalency with respect to A implies equivalency with respect to B. So really, to show equivalency in an overall sense, all you have to do is show equivalency about any convenient point. You get to pick the point. You pick something that's convenient to do the calculations with respect to, and that allows you to show equivalency.